So just want to show you a very quick overview of my latest changes as I was working on fixing error messages. So once again, the simple window was missing the header guard. I added comment for the simple window. I added the header guard, and of course it requires the and if at the bottom. Okay, so I did this. I also inside the game.cpp I added the include because it was missing. And likewise in game.h, because we're using all of these elements, I also added these two includes to the header file for game class, right? So these are the things. Simple window header guards, include in game.cpp, and two includes right here. Right, and I also had to abandon these attempts for me to use the standard library back member function because apparently the current implementation inside the book gadgets does not support it. So maybe in the future it will support them. So I just commented out these things that I attempted, but I will not be using it. Okay. Anyways, let me highlight very quickly the organization of the game class, and then we'll do the final step in this lab. So let's just open another whiteboard and just want to highlight one more time is that when I have this game object, it contains two things. It contains hidden words, right, and which is a collection of integers. Okay, so it's like hidden words is a collection of integers like this, and each integer is stored individually. It's a collection of integers that looks like this. We also have T-Rex, which is a collection of references let's make it visible, to the rectangles. We create rectangle objects, actually text rectangle objects. Text rectangles are created, these objects are created dynamically. Okay, so we construct them dynamically as we reading words from the sentence. Okay, so we construct multiple instances of these text rectangles dynamically, and one is constructed for every word that we read. So when this happens, this collection of T-Rex right here, a reference vector of text rectangles, is populated with the references to these objects. Let's just adjust this a little bit. I have to move it like this, and just to show you that basically when we populate it, this will be a reference to the first text rectangle right here. This will be a reference to the next text rectangle that we create, and this will be the reference to the next, and this will be the reference to the next. And as we add more over here, we will populate more over here. And then when we find hidden words, if we say that, for example, we want a specific word to be hidden right here, okay, two of these. The indices, which are 0, the indices which are like 0, then 1, then 2, then 3. So the text rectangles 2 and 3 is supposed to be hidden initially. So what we do is we store their index in here in hidden words. So this collection is T-Rex collection, and hidden words is a collection of indices of hidden words. So index 2 and index 3 are stored in this collection. And of course, a collection of hidden words is simply pointing to these references that's supposed to be hidden. And so this is how it's all organized in memory. Just wanted to do this quick demonstration of these two collections and how we dynamically construct text rectangles, populate this, and if we consider the words to be hidden, which I make with a gray shade, we add their indices to the hidden words collection. Just wanted to make sure that we kind of address this. And so this is pretty much wrapping up our lab, our final project. It's working, except that if we could still spend maybe like 5 minutes, we should complete the final part of it. What says when it says more things to do is that how about we start reading sentences from a text file. All right, so I'm assuming that when we start running our program inside this Visual Studio testing environment, it starts in the same directory where the project directory is located. So how about I go to the final project location and create a new text document, which will be which I can name program input. Program input. I need to spell it correctly, right? So this is the name of the file, and it's an empty file. This is program input, okay, and it's an empty file. And right here in our main GUI, I will just say that we now have the task to replace ISTR with an input from a file named program input.txt. So that's something that we want to do. So step number 1, we'll take these sentences because they already exist, and we can continue continue using them. Right, so just add them to the program inputs and get rid of quotes because we no longer need them. So just get rid of these quotes like this. And now we have a file with this same content. Of course, what we can do is we are going to, for now, I just comment this part out. Say, okay, let's replace this Memory buffer, if you remember that we were discussing its creation right here. So now this will be replaced with input from a file. So this temporary helper class with that contained all the text in memory is now gone. We'll be replacing it with the file. Of course, to work with files, we need to include uh, include of fstream, which contains declarations of classes that work with uh, input files and output files and all the streaming library for files. So what we're going to do is we're going to declare input file stream, and I'll use the same name istr, so I don't have to do many changes, right? So we can declare it like this, and now we can just open the file immediately by saying, let's try to open this file. Okay. So then typically we would, so constructor like this will automatically open this file for input because this is input file stream. We can make a quick check for something like this, like uh, if the if this file istr is open. So we're saying if it's not open, something wrong, like it's missing, we can tell the user that again we can construct this type of stream and populate it with information that would say program input.text. This is hard coded, but you can modify it. Does not exist. And then we can construct the game class, right? Just like we did before, the game class. Okay, just basically do the same stuff. Copy and paste all of this. Okay, and we can then return 1, which indicates that something is wrong. And with the rest of our program, everything should be pretty much the same. I'm expecting that it should be very much the same. The the file will be closed as soon as we're done. So let's just see if we can build this. Illegal break. Oh, yeah. So we don't need the break right here. We just we can say error. I think error. Okay. Right. So let's build. All right. So so once again, let's temporarily rename this file. Just temporarily rename and like add an like underscore in front of it. So then once we start testing, if our assumptions are correct about uh, about the code here, so if I run it, Let's just make an adjustment.